Hi students, today we are going to do the revision of the chapter Work and Energy. So first, in our everyday life, we have heard about the word work. Also, everyone at home is doing some work or the other. But according to physics, what is meant by work is very interesting. In the field of physics, when is work said to be done? All the activities whichever we do in our everyday life cannot be called as work according to physics. So if work has to be done means two conditions must be satisfied. So what are the two conditions to be satisfied so that work is said to be done? So condition number one is force must be acting on a body. Force must act on a body. Okay, if a force will act on a body, suppose you take, I will consider this wall and this board itself, I am going to apply a force. So I am pushing this board inward. A great force I am applying. Am I doing work here? Means not at all. Though I apply a force, now work is not said to be done here because the second condition is also very important. So what is the second condition is displacement must be produced. So there should be a displacement must be produced. Mostly the displacement must be produced along the direction of the force. Suppose if I will take this pen itself as an example, when I apply a force, lifting force I am applying on it, the lifting force. So when I apply a lifting force in the upward direction, the body is also moving along the same direction. So here work is said to be done because both the conditions are satisfied. So what are the two conditions? When is work said to be done? When the two conditions are satisfied. First, a force must act on the body and displacement must be produced along the direction of the force. Okay students, now I will consider an object is placed on the ground. So this is a wooden box which is kept on the ground. Now I am going to apply a force. So I tie this to a rope and I pull this with a force F. So that this object is moving along the direction of the force. So the object has moved to a new position like this. So that with respect to its initial position, this is the direction of the displacement. So I will consider A is the initial position and B is the final position of the body. Can you see here a force F Newton is acting on the body? So that the body has moved from a position A to a new position B along a straight line. So you must be knowing that the distance moved along a straight line is nothing but the displacement, that is denoted by S. So this force acting on the body has produced a displacement S. Do you agree a work is done by the force? Yes, work is done by the force. In this case, I can define work done. Okay, in this case, the work done by the force is equal to the product of force and the displacement. So if you represent work done by capital W, then it is equal to force into displacement. So this is the general definition at the beginning level. At the beginning level in the 9th standard, anyone must know that work done by a force is a product of the force and the displacement. But at the higher level when you go means in terms of vectors, we are going to define. Understand students? So at least now at this 9th standard level, we must know that work done by a force is defined as the product of the force and the displacement. And you must be knowing that force, the SI unit of force is Newton and the SI unit of displacement is meter. So what must be the unit of work done? From this equation, what is the unit of work done? That must be equal to Newton, okay, Newton into meter, Newton into meter. So this is a capital N for Newton and a small n for meter. But as a respect of James Prescott Joule, there is another unit also for work done, that is nothing but Joule itself. So work done also, this is also equal to Joule, capital J for Joule. So I can write here 1 joule is also equal to 1 Newton meter, 1 Newton meter. So both Joule as well as Newton meter, both are units of work done. Okay students, say for example, I will take a body, okay, is placed here. I will apply a force of 1 Newton and it is producing a displacement of 1 meter. I have taken, see, this is the force acting on the body is equal to 1 Newton. Because of this force, the body is displaced by 1 meter. So this is the displacement. Therefore, in this case, W is equal to 1 Newton into 1 meter, that is equal to 1 joule. Okay. So now we have defined the unit of work done. So what is the SI unit of work done means? You shall say hereafter Joule or Newton meter also, but preferably you can say it is a joule. So how will you define 1 joule? How will you define 1 joule now? 1 joule is defined as the work done, okay, by a force of 1 Newton acting on a body which produces a displacement of 1 meter along the direction of the force. Okay students, so we have now stated the two conditions for which the work is said to be done. Secondly, we have defined work done as the product of force and displacement. Thirdly, we have defined the unit of work done, okay, that is the unit of force multiplied by the unit of displacement, that is equal to Newton into meter, which is also equal to joule. And then we have summarized this, 1 joule is also equal to 1 Newton meter. Later we have defined 1 joule. So 1 joule is equal to the work done by a force of 1 Newton acting on a body which produces a displacement of 1 meter along the direction of the force. Okay students, now we will be going to the next level. Until then, wait.